Hello everybody. Yeah, I slightly changed the title, but you will see why I changed it during the presentation. On the top of that, you may see that there is two names for this presentation, but I will be the only one talking today. I have spent more than 26 years in the oil and gas industry, and I'm working since a few years now with NEL, and my title seems to refer to international business and marketing. However, some of you probably know me, and I'm much more on the technical side. So I will try to keep the 1 hour that was mentioned by Marietta just before. And let me just get those things in the right way. I have a technical problem. Okay. Well, obviously, everything that I will say today, if someone needs to blame it, it's on me, definitely. So the contents will be a quick overview of what is NEL, if you don't know about NEL. And then I will develop my talk around the new facilities that we have here. And very often on my slide, you will see I call it AMF. AMF is for Advanced Multiphase Facilities. And through this new facilities that we are building here, or which is built now, I will propose and discuss about joint industrial project about validating the measurement of multiphase flow meter and wet gas meter. The second part of my main talk, will be related to a new device that we have been developed here, and this will bring me to a second GIP that we want to propose to everybody about what rocket meter. Okay. Some of you may know that there is another GRP on the way, but I will not have the time to speak about that during this presentation here. So, NEL, National Engineering Laboratory, we are on a campus here in Scotland, okay? And as I said on this slide, it's a one-stop over, for anything related with flow measurement and density. Could be in single phase, could be in multi-phase. NEL is an independent and impartial company, which is part of a much bigger corporate company, which is called TÜV SÜD, and this is why you can see the logo with the two companies on the left side. So NEL was established some time ago, just before I was born, and went through different process, and I would say the key one was in 1995, where NEL was, as I mentioned on this slide, half a public company and half a private company. And this is what I mentioned previously, with the fact that we are part of the TÜV SÜD corporate now. NEL is, and that's something very, very important to remember, NEL is a National Measurement Institute, so we are primary calibration facilities for single phase measurement, could be in gas, could be in oil, and could be in water. We are conducting some research on behalf of the UK government, and we're getting some funding from them, so this is why, again, I'm explaining, I'm mentioning that we are a public company. We are roughly 100 employees here, and 10% of doctors and 45% of engineers. And really the core of our work here is about traceability, accuracy, and calibration in the first place. So what are our customers? We are in oil and gas most of the time, and I give you some logo here. And if we look at on the metering side, through the survey that we have done, it seems that we have handled more than 98% of the products existing on the market in terms of flow measurement, either in single phase or in multi-phase. So our structure is a very flexible structure around three main poles. One is on the research and development. The other one is about facilities and experiments, and I will show you the latest one, And in green, the services that we are providing to our customers around the world, And then people can interact between these three main poles. We have some a pool of international experts in different domains, that will float among these three entities. On the top of that, we are known to work on standards, with some of you probably, on API and the ISO. We have a lot of interaction with universities in a different area. And one of the strengths is being independent. We are sharing our knowledge through either conferences or training. So this brings me now to something unique, new, and I will try to explain you how we came to this solution here. What you will see is, you see the summary already, you know, it's 20 times bigger than what is existing around the world, and I will justify this statement just after. You may be surprised to see another logo on this slide, but obviously to develop this facility, which cost roughly $21 million, we needed some sponsor, and this came from the mother company TÜV SÜD, but also from the Scottish enterprise, which was capable to support this new project. So, building a new facility could be something interesting, but in the same time, NEL had already 9 facilities, you know, by 2014. We have few facilities on single phase for calibration under water or oil. We have also capability to look at calibration of single phase under pressure and temperature. We have some erosion flow loop, and we are also deeply involved in produced water. So we are looking at the contamination of the water, either with some sand or oil. So obviously, you can imagine when you have such portfolio, you know, you try to improve your product over the time, you know, and you reach the time around 2014 where we saw that we will not be able to address the market in the future beyond the 2020, and we needed to change the way of thinking about that. So to invest money, you know, first thing that you need to do is to have a proper understanding of the market trend, and this is what we have done, interacting with our key customer, which I'm listing here in a generic way, you know, which is in oil and gas domain, you know, like a national oil company, international oil company, or some independents. The instrumentation and manufacturers, obviously, what do they want in the future? The EPCs and also some legal authorities and the UK government. So what came out, you know, over these 2 years of question and answer, it's this slide here where I have the 7 main bullets, you know, all the ideas you can imagine. It's a lot of people will have some ideas and some nice to have, but for us, what was key is to see what will be permanent over the next 20 years when we will be developing these facilities. And the 7 bullets here represent different topics which are quite important. You know, the first one is referring to the subsea market. There is a big interest in the subsea market. You may know that it's growing, and on the top of that, they want to be able to test and verify the performance of the meter, you know, in independent and impartial way. So they needed a facility capable to handle large flow rates, capable to go to a higher pressure. The second one, I just mentioned it before, you know, it's in the subsea market, you will go with high pressure. Most of the facilities existing around the world, you know, are at 60 bars or below, and then they wanted something to go way above these things, okay? The business also has been moving over the years, you may know that. We were in the oil industry, and more we are going to a wet gas industry, so they wanted a facility that is capable to address the wet gas meter and be able, you know, to accept a large quantity of liquid when it was necessary. The fourth bullet, you know, is referring to the fact that the business is moving to the gas side, but they want to have a facility which is capable to deal either with oil well or with gas well, and they can test one meter in the 2 different business, you know, in one go. The fifth bullet is referring to flow rate. Flow rate, you know, coming from the tieback on the subsea side, but also on the FPSO, on the production manifold, or even on the subsea well, you know, there is completion with 8-inch, 9-inch. It is not uncommon now to see meters and multiphase flow meter and well gas meter in a range of 10-inch and above. Okay, so they wanted to have a facility where they could look at the performance and identify clearly what will be the uncertainty associated with the measurement. The number 6, is referring to the fact that to get a good uncertainty, you need to have a very accurate reference measurement and something that can be audited in a simple manner. And the 7 is referring a bit to everything before, but adding also the fact that they wanted to be able to change the pressure to see the performance of the meter, or change the salinity of the fluid, or change the water contents or the gas contents, and look at the performance of such meter. So we had here the main drivers, and all the idea now is very simple, if I can say it, was just to build something around that. So I'm right now, in this square, the yellow square, here in Scotland, close to Glasgow. The red buildings, if you have been coming to our campus, it's where we have most of the facilities, and some are behind that. And the new buildings, it's the one inside the white square just in front of us. Okay, so it's a Reynolds building, and this one is dedicated to one facility. So I give you a bit an idea here in terms of size about what we are talking. So this building is 80 meters long by roughly 20 meters width. If you prefer, it's almost half of the size of a soccer field. And this is where we will have these advanced multiphase facilities inside. So I try to put some boxes, I will show you just a few pictures after about what we have inside this building. So on the right side, I will start from the right side and go to the left. On the right side, the purple square, it's where we have our pumping facilities and blowers. So we have 2 pumps, and you will understand why there is 2 pumps soon. 2 pumps for the oil, 2 pumps for the water, and we have 2 blowers, gas blower, for the gas. The yellow square, it's the room where clients will be able to stay. The red box, it's the room where you will have the control of all the facilities. And if we go up now in blue, it's where we have all the reference measurements, and I will list them just after. In the black, this is a manifold where we will be able to flow either in standard configuration in a 10-inch line or a 6-inch line. The green part is where we have this test area, where we can have a manifold, a multiphase flow meter, or whatever you want, to be tested here. And if we go back to the bottom, you can see in orange the separators, and I will show you a picture of the separator and the pre-separation shortly. To give you an idea here, the separators, for example, is 33 meters long and almost 3 meters in diameter. So you may start to feel that this facility is huge, and definitely we will be handling large volume in terms of flow rates. Give you a picture, if you are not in a soccer, you have 2 track trailers on the left side, that can go in and out of these facilities to bring equipment and so on. So let's look at the 2 pictures. This is how it was the facilities a week ago. In blue, if you look at the pictures on the left side, in blue, 8 meters height, you can see the separator 33 meters long. This is where you will have the gas, the oil, and the water, and they will be pumped through the system that I was mentioning earlier. Again, we have an investment here of $21 million supported by the Scottish enterprise and TÜV SÜD. On the right side, you can see some of the valves, to control the flow rates, and if you look at carefully and a bit in the middle, you will see on the top a bluish part, which is a separator again. So this is a facility as it is today. We have, for reference, on the oil and water, they are twins, if I can say that. We have a 1-inch, 2-inch, 4-inch, and 6-inch Coriolis. And for the gas, in terms of reference, we are using either Coriolis for low flow rates or ultrasonic for large flow rates with a 3-inch and 8-inch. Okay. All this equipment obviously needs to be calibrated under pressure and temperature. You may know that Coriolis are affected by these parameters, and we have the capability here through one of the other facilities, to do this calibration and traceability, which is essential in this business. So, what are are we talking here now with this big building and this big pipe in terms of flow rate? So you can see it on this slide. In terms of oil rate, we will be between zero, virtually zero, you know, and more than 83,000 barrels per day. If you pressure in cubic meters per hour, we will be reaching 550 cubic meters per hour only for the oil. The same thing for the water, as I said, it's between. And for the gas, we will be reaching 358 million of standard cubic feet per day. Or if you prefer at line condition, you know, in cubic meters per hour, roughly 3,000 cubic meters per hour. The uncertainty that we will have on this equipment, you know, it's under process right now, but the target is to be below 0.5%, like we are on the other facilities. Now, I was talking about pressure. We will be able to handle pressure from roughly 200 psia, you know, to above 2,000 psia or 15 bars to more than 140 bars at the test section. The separators, for example, will be always around 150 bars line pressure. Temperature, we will have the capability to change the temperature between 10 to 43 degrees C. The TS area was mentioned before, you know, it's quite a huge area. The height in terms of equipment that we can put, you know, on the test is roughly 10 meters. And we are capable to go from 0 to 100% gas volume fraction, and the same thing with the water cut. What are the fluids that we'll be using here? We use refined oil. We are very comfortable with Exol, and here we are using the Exol D140 for some safety reasons. In terms of water, we will be systematically using salty water, and in a conventional configuration will be between 2 to 6% of NaCN inside this water. For the gas, we are planning to use, like on the other facilities, some dry gas, and this is a nitrogen that we know quite well the behavior with the Exol and the water. In terms of pipe, we start around 2-inch pipe, and we can go beyond 14-inch and whatever you want, you know, after it's a question of velocity or flow rate that we can achieve. We have been, on the top of that, buying some subsea choke valves, so we could simulate, for example, some condition upstream or downstream of wet gas meter or multiphase flow meters on its own here. You know, this is an option available. And the facility is going right now under the certification to be like the other one on ISO 17025. So, we try to look at now the working envelope. You know, when you have a facility, the first thing that you want to do, you know, after having the max and min in terms of flow rate, you know, is to define what is the envelope that you will have. On the x-axis, I'm presenting the gas flow rate in a million of standard cubic feet per day. And on the y-axis, I'm showing the liquid flow rate in barrels per day. What do we see here? It's we will be reaching, as I say, more than 300 million of standard cubic feet per day, but we will be able to address what is presented in red, which is the wet gas area. You know, for some of you, you know, in oil and gas, this means we will be with CGR from 0 to something around 20 barrels per million of standard cubic feet per day. We have the gas condensate in orange, which very often we refer in CGR between something around 40 to 125. And then after we go to the volatile oil, which is much more represented by GOR, in this case, gas-oil ratio, in a range of 5,000 to 4,000 standard cubic feet per barrel, you know. Then we have in brown the black oil, and we can go for the last part in gray, which could be the heavy oil, but here it's much more addressing with such flow rates, you know, the production facility when you have been separating already the gas, for example, from the liquid, and you want to look at the performance of a meter with barely the quantity of gas flowing inside, you know. So this is to give you an idea, you know, if I look at it versus CGR and GOR, and now I'm presenting it on exactly the same data than before, just I change the scale now from linear scale to a logarithmic one, and I've been presenting on the top of the AMF envelope the two other facilities that we have for wet gas and for multiphase. So we have in red the multiphase low pressure facilities, which can go up to 14, 15 bars, 200 psi, and really dedicated for versatile fluid, low flow rate, 2-inch to 6-inch, either black oil, volatile oil, or heavy oil. We can handle fluid up to 2,000 centipoise in these facilities at line condition. We have the high pressure wet gas facilities, which obviously called high pressure at that time. Now we have a bigger pressure with AMF, but it's in blue, and it's addressing wet gas business and gas condensate essentially. The loading or the quantity of gas or liquid that you will have will not be above 15% in a base case. So you work with a condition where the quantity of gas is large. And we have the AMF, which is capable to go either on the liquid side or the gas side. And this is to give you this idea about the offer that we have here from low flow rate viscous fluid to high flow rate, low viscosity, or wet gas condition. So I say that we have a pretty unique facility. So one of the things that you need to do is to position your product against or versus what is existing on the market. And I'm presenting here in this spider web graph, the pressure on the top. At 3 o'clock I present the oil flow rate. Around 5 o'clock I present the water flow rate. Or 7 o'clock you can see the gas flow rate. And the investigation range, which is roughly at 9 o'clock. So I've been looking all the different facilities existing around the world, and I've been, when they were the best, I give them 100%, and then everybody is ranked between a scale of 0 to 100%. And what you can see in the dark, probably blue or black, I'm a bit colorblind, so I cannot see very well here. You see the range or the domain of investigation that we have, which is something totally unusual. And this is what makes this facility pretty unique. I give you again the working range on the side to have a good picture of what we are talking here. So, stated in a different manner here, there is one facility that can go much higher than us in gas flow rate, probably 50% more, and the pressure, there is one facility capable to go higher in pressure, but they are not capable to deal with such quantity of flow rate that we have here. So, what it means when you have such a facility, it means that we can look at any type of flow regime and the performance of the meter in such condition. I'm presenting here, in this 1 hour time that I have only one type of flow regime, which is the horizontal one, but you can imagine that the flow could be vertical if we want, and we are capable to address any type of them from mist flow to stratified flow to bubble flow, plug and slug flow, annular or pseudo-annular flow. This is the capability of these facilities. You connect the meter and you can look at the performance in such flow regime. So, what are we capable now with this institute here on this campus, to address in terms of business? We can go from the brown, even the heavy oil, to the green field. We can address from heavy oil to wet gas condition. We can address shale oil, shale gas, low pressure, either with a lot of liquid or gas, up to a business, in the subsea where you will be in a wet gas condition with high pressure, which give us also this capability in terms of pressure to go from very low pressure on one of our facilities to 141 bar on the AMS facilities. Gas virtually from 0 to 450 million of standard cubic feet, so you can imagine we are not talking about wells. There is few wells that can do these things in the world, but most of the time 350 million will be probably when you have a commingled production, from few wells. In terms of liquid, as I said, each phases can go up to 80,000 barrels per day, so it means together will be 160,000 barrels of liquid per day. And we can address any problematic that you may have today, in terms of solid, like fine or sand, erosion or monitoring, and we have a facility capable to handle up to 10% of such quantity. I mentioned it earlier, we are working a lot on the produced water, and we can look at the contamination at the ppm level that is presented on this when you are a National Measurement Institute, you know, NMI, you need to be on the top of the work that you are doing in terms of uncertainty. You need to have the smallest uncertainty, smallest number, or the highest quality. It depends on how you want to look at it. And I try to rank on the right side, you know, the different facilities that you may find around the world, and not of the, some may be cheaper, some may be higher in terms of price, but it is very often related either to flow rate, pressure, or the quality of the measurement that is given by the references. Okay? So it goes from manufacturer having facilities or universities where usually there are low pressure, the uncertainty is not the greatest one on the market, but it's very good, you know, to develop a product. And then after, you will need either to go through a calibration of third-party calibration facility, and finally reaching the highest standard, you know, a primary calibration facility like NEL. Okay. Some of them, you know, I show it in purple, could be ISO 17025 or not. This is something that also changes the quality of the facility where you are going to test your meter. So, and I want to answer right now one of the questions that very often I have, you know, when I'm presenting the MF. It is regarding the type of fluid that we are using, you know, and I mentioned it earlier. The three fluids that we are using are Nexol, salty water, and the nitrogen. And everybody say, yes, but, you know, well, in the field I have some live fluid, you know, and are you capable to handle such things? So, you know, you may not know exactly what is dead fluid and live fluid, but I give you some shapes of bottles, you know, and you may understand what I mean. Some have some gas dissolved inside, and some have no gas dissolved inside. And this is what people are talking about, fluid, dead fluid, or live fluid. Okay. So, first thing that we need to understand is if you are coming to these facilities, it is to test or to validate a multiphase or wet gas thermometer. So we need to provide the best uncertainty measurement, and we need to do this work, you know, in the first manner in terms of evaluation, either for the manufacturer or for the end user. Okay? And keep in mind, this is what I mentioned, there is a warning here. The expectation of the manufacturer and the expectation of the end user are not the same. And you could be surprised by that and say, well, we know they are developing a multiphase thermometer, and the idea is to get the best performance. If you look at it from a manufacturer point of view, the idea is to provide a product which is capable to deliver the highest or the best uncertainty at line condition. Okay? There are experts in some technology, and they combine this technology to develop a multiphase thermometer or wet gas meter, and therefore they try to improve or combine in a smart way these techniques, you know, in order to deliver flow rate at line condition. But as we know, at line condition, you may have some gas dissolved in your oil, or some liquid, you know, condensate, you know, which is in gas form and will become liquid at standard condition, and therefore you will need to convert these things through some PVT, you know. And why I'm saying that, it's because the end user, and when I'm talking about the end user here, will be the oil and gas company, what they want is flow rate at standard condition, because they are paid on the volume that they are delivering, you know, at standard condition. So you can see that one is looking on the technology and the hardware side, and the other one wants to look at not only the technology, but also the way you handle the fluid and the conversion from line to standard condition. So this brings us to the two next bullets. You know, the first one, it's as a facility owner, you know, you need to find the best products that are capable, are on the market, you know, in order to control very well the concentration of gas, for example, which is dissolved in your liquid. You need to have a high accuracy, you know, on your instrumentation. And if you know a bit the standard, you know, you need to reach a level of quality that should be 3 to 4 times better than the expected specification of the meter that you will be testing on your facility. If you are not reaching this number of 3 to 4, you will need to take into account the uncertainty of your facility to claim the performance of the multiphase thermometer. And keep in mind, today on the market, we have some multiphase thermometers or wet gas meters that are claiming to be within 2 to 3% in some of the phases. So therefore, you need to be sure that you provide an uncertainty in your reference measurement way lower than 1%. Okay. On the other side, we need to face it, developing a multiphase reference flow meter, it's a complex system, and the uncertainty will be a combination of the model, the physics that you will be using, the instrumentation or technology that you will be using, and also the fact that you will need to have some information about the fluid properties and the conversion that you will need to do about that. So this is what you are dealing with when you want to look at a performance of a multiphase flow meter or WGFM meter. So if we look at it in a simple manner, we have the reference condition, which are delivered here by a facility, on the left side, and then we have some measurements which are done with a meter. Okay? And all the idea will be to do the comparison between this cylinder, red for the gas, green for the oil, and blue for the water. So to do these things, you will need to use some numbers or some parameters, and I show you the list here of parameters that you will need to use to do this conversion if you are in a field condition. So you will need the BG, the BO, and the BW, you may know that. It's related either to the expansion of the gas versus pressure and temperature, or the shrinkage of the oil and the water versus pressure and temperature. The other parameters, starting with the R, are referring to either some oil, which is in a gas form, or the water, which is in gas form, or the opposite, some of the gas which is dissolved in the oil, or some of the gas dissolved in the water. You know one of them very well, for example, the CO2, it's in all your Sprite that you are drinking, and it can be dissolved very well in a gas, in a water like the H2S2. Okay? So now we start to understand that comparing the reference measurement and the meter performance or meter measurement, you will need to use either an EOS, equation of state, typical of software, or a PVT table or something to do this conversion. Okay? So if we look at carefully now NEL, I'm always referring to NEL, like a facility where we have non-miscible fluid, but if I want to be fair, as soon as we reach a bit of pressure, we get 60% of nitrogen dissolved in oil, and we get roughly 1% of nitrogen dissolved in the water. So this means that probably I will need to use all these parameters to do a proper conversion, from reference condition to meter condition. And is it a good news or is it a bad news? Probably if I present this slide like this, to the oil and gas companies, they will say, well, this is very interesting, you have some gas dissolved, so we are much closer to field condition, even if field conditions are way different than any facility in the world, But on the manufacturer side, they say, oh, now you have some gas here, so probably the uncertainty of your facility is increasing. So I will make the statement right now because some people could be scared now. There is a good news. It's yes, we have some dissolution of nitrogen in the oil and the water, but if I look at even 60, 70 bar of pressure loss, like I present below, between 38 to 122 bars, the concentration of gas that will come out of this solution, it's way below 0.2%. So here on this slide, on purpose of this presentation, I'm just saying that it can be negligible. Therefore, we can do the comparison at line condition, the reference and meter condition by removing most of the parameters that we have here and keeping only the shrinkage factors and the expansion factors. And this is great news from a manufacturer point of view. Now, if we want to do a proper comparison at standard condition, here I will need to use the PVT conversion, okay? And then it will be a nice way, to demonstrate the performance, for example, of a multiphase flow meter, using not only the technology, but also the conversion or the package that they have to convert from line to standard condition. And this is the beauty of this facility, where we are capable to deal with high pressure, therefore a lot of gas dissolved in oil, and following how we do this comparison, taking into account or not the uncertainty associated with the PVT package. Okay? So, all this long talk about the AMF, Advanced Multiphase Facilities, is to bring you to topics that for me I feel extremely interesting. It's NEL try to contribute, and share knowledge, and they want to propose a joint industry project, GIP, We have been doing GIPs in the past, we have one in the 90s, mid-90s, one close to the millennium, and one just after the millennium, which were addressing different topics. I will not go through this slide in details. You will have it. You can see the oil companies that were participating to this GIP and the manufacturers that were selected by this steering committee to be tested one after the other, on the different facilities that we have here. So what we are doing today is over the last 9 months, we have been starting, Anna and I, to go around the world and to promote a new GIP based, and the motivation is based on this slide here. We have seen the market growing more and more, in terms of use of multiphase and wet gas flow measures. And there have been, over the last 5 years, a lot of new kits on the ground, as I said here, and there are some innovative ideas, different perception. We have seen also a trend in the business where people are more reluctant today to use radioactive sources, so the latest technology try to avoid it. Are they better or not than the old technology, as I said? So this is something that's probably interesting to look at. I mentioned it earlier, we have a change in our business, from the oil side more and more to a cleaner or green with a wet gas condition and gas condition. So obviously we need to look at the performance of the meter in this area. And some of the wet gas meter claim they can work in multiphase condition, and the opposite, some of the multiphase flow meter claim that they can work, in wet gas conditions. So all these things means that there is motivation and interest to look at what we could be doing with such meters today on the market. So on the top of that, the last GIP finished in 2010, and most of the products tested in 2010 are not anymore on the market, or they're obsolete, or they have been changed. So therefore, I think there is a good opportunity to develop a new GIP. And the idea is obviously related to three things, which will be the combination of the technology that they are using, that they work or not, the sensitivity of these parameters that you input to the meter, and obviously the PVT package going from line condition to standard condition. So, what are we planning to do here? We are planning, in terms of GIP, we are planning to have a steering committee with all the oil and gas company. Manufacturers cannot participate to that. And we will be selecting some meters. They will be selecting some meters, and then we will be testing this meter one after the other. All these meters will be tested in a blind way, and the data will be available for each meter to the manufacturer, and all the data for the steering committee. Okay. The idea, obviously, is to look at what I said earlier, and I will not spend too much time on this slide, but to look at the salinity change, the pressure change, and all the conversion from line to standard condition. So, what are we planning to do? We are planning to look at least 3 different pressure, 2 different salinities, 11 different GVF, 9 different WRR, and I hope we can test 4 multiphase flow meter in one go and 4 wet gas meter in one go. I give on the side, and you will have it on the PDF that you will get, from my presentation, some names. I'm not saying that we should use one more than the other. It will be up to the steering committee to do that. So the idea is to look at the low range, the middle range, and the high range of these meters, is to look at, in terms of GVF versus WR, what we are capable to achieve in terms of uncertainty for wet gas and for multiphase flow meters. So at the end of the day, I'm expecting that we will have for each meter more than 1,700 data points at different pressure, different GDF, and the price to participate to such GIP, is presented here. It will be roughly 160,000 pounds, over 2 years. So the first year you will need to pay 80,000 pounds, and the second year 80,000 pounds, and then you will get access to all this data. For the wet gas, it's the same story. So multiphase and wet gas program are the same. It's the same GIP, and the conditions are just different, and we get here another 13,000 data points, you know, to look at the performance of such product. So the idea of this GIP number 4, you know, it's really to look at the performance of the multiphase flow meter and wet gas meter in the upstream oil and gas business. Okay. This is open to you. Some of you will be contacted by me or Anna. We are planning to go for another month around the world before we close the first round, you know, and then we start to present to the steering committee what we are planning to do. Okay. So, advanced multiphase facilities is not only related with the pipe, it's also related with new products that we have on the market. And I will go very, very briefly to one of them. Nel has been investing a fair amount of money, and we have today a tool which is a 2D 3-phase X-ray devices. It's a tomography product, you know, capable to go to high frequency. And I will show you some pictures of that, you know, and the beauty of what we can achieve with such equipment. X-ray, all of you, you know the X-ray, at least you have seen the black and white, you know, when you go for your chest X-ray, there is some new products that are existing in the hospital today where you can have a nice color one. What we have done is to take such system, you know, and develop it for pipe configuration in our case, and look at the 3 phases, oil, water, and gas. Okay. The product that we have was made by a company in Norway, you know, and we have a very high acquisition frequency, reaching 180 hertz or 180 frames per second, you know. And we use X-ray here because we can look at, we can penetrate a pipe and look at the section, the full section of this pipe. So what are we getting? You know, it's such a picture that you see here. On the right side, you see an X-ray generator on the top and an X-ray generator on the side, you know, and then they are beaming the same spot, you know, on the side and on the top, and you get two pictures here. Adding these two pictures, you know, versus time, we are capable to generate, because we numerize everything nowadays, you know, or digital if you prefer, and we are capable to look at, for example, on one pass number 1 here, the Holdup in terms of oil, water, and gas. But we can do much better than that. We can look at, for example, the interface between the liquid and the gas. We can look at the concentration of the holdup that we have in gas or in liquid. We can even look at, you know, make the distinction between the water and oil and get access at high frequency on the WLR measurement. Okay, and obviously something beyond is to look at the structure of the flow. Look at, you know, if it's a sluggy flow or not, and what are the lengths, what are the frequency of such things. So here you can see, for example, the pictures on the left side, you know, where you see a sluggy behavior, but on this horizontal pipe, we were injecting exactly the same quantity and stable quantity of oil, water, and gas, and what you were expecting is what is presented on the right side. Most of you, you know, the fluid mechanics is not as simple as that, but you can see the different pictures between what a model may be assuming, you know, or what you may be assuming when you develop a multiphase flow meter, and what is the reality on the other side. Okay, so having this new product here, and seeing a lot of interest from manufacturers, you know, to look at end user and manufacturers to look at the performance of water cut meter, we decided to combine the MF with this product and look at what we are capable to achieve in such case. So, you may or you may not know that each time we produce 1 barrel of oil, you know, we are producing 3.5, in average, 3.5 barrels of water, and therefore, you know, this is a loss of money because we need to process this water. So, first, this water cut meter, are they working in all the conditions? For example, in a horizontal pipe, I show you, you know, with some sluggy behavior, does it work or not? This is all the question. Very often nowadays, wet gas meter, you know, are developed and are capable to give good accuracy on the gas and fair statement on the liquid, but they never mention the difference or they never distinguish between the oil and the water. So obviously you need a water cut meter in such conditions. So there is a need to look at the performance of such equipment, and even in a different manner, if you want, if you look at the life of your gas well, you know, you will go from hydrocarbons production to something which will be more watery in the future with a fair amount of liquid produced with the gas. So again, here there is an interest to look at this water cut meter. There is plenty of water cut meter on the market. I have a list of 14 of them, and I'm sure I'm not addressing all of them on the market. So all the idea, what are they doing? Are they good? The pricing are more than a factor 10 between themselves, So there is definitely something to look at here, and this is why we're opening this GIP number 5 about water cut measurement. So here we are planning to do exactly the same thing than for the multiphase and wet gas facilities. It's to make a program, okay, over 2 years. Here the participation is slightly lower than the previous one. It's 125,000 pounds over 2 years, We are expecting that we will be selecting 6 to 7 water cut meter, and we are expecting to get 7 oil and gas company, and therefore we could look at the 6 to 7 technology, in one go and see the performance of such equipment, either in a low water production or very high water production, or around the inversion phase and a different type of GVF. This is what this slide is presenting here. Okay, so remember there is a joint industry project number 4, which is associated with multiphase and wet gas meter, and this number 5 here is addressing the water cut performance and looking and screening what is on the market today. So now I'm reaching, and I'm sure I'm slightly late, the main conclusion on what we are providing here. So on this campus now we have a new facility, the MF facilities, which can go high pressure, high flow rate, as I mentioned it, and we have all this portfolio addressing the knowledge in terms of either solid in a liquid, gas in a liquid, and we have some new products around that, like the X-ray 2D 3 phases tomography, which can look at what are the flow, the type of flow that you have in your pipe. Is it sluggy or not? Is it more misty flow, or is it more bubble flow? All these things are the things that we can do here right now. So information about the GIP are available on the website. Okay. You can contact me, or you can contact Anna for any of this GIP. As I said, we are still going around for a while, and we will close this first round, as I said, in next month, and we will have a review of these things by October. So I think I finished here, Anna. Oh, Marietta.
Okay, thanks for that, Bruno. I think we've maybe got time for 1 or 2 quick questions. If you just bear with us just for 2 minutes till we pull up the questions from the chat.
So let's take one first question, which is about the MS facility. Is it available or not to test meter right now? Yes. In fact, our first commercial jobs are starting in August this year, and the facility is available, obviously, to do any tests. Quite amazingly, we have some small meter 2-inch starting on this facility, and also some 14-inch starting on this facility. What are the other questions that I can pull out? Let me read it. Yeah, so this is a typical question that I'm getting, what do we do, what can we change the gas, very often they ask me, can we change the nitrogen to the natural gas? Yes, I wish we can do that. The first thing is to understand what they mean by using natural gas. If I can use natural gas in these facilities at high pressure, high temperature, or no, or definitely I don't want to be around, because it will be probably a bomb that I'm building in this case. Now, if you want to use these facilities to look at how the performance of the meter with some dissolution of gas inside the water and the oil, the facility is already available with that, with the nitrogen. You could imagine if there is a special demand that we can add some CO2, but for a safety point of view, we will not at all put natural gas inside this facility for the I think I will stop here.
Okay.
Okay.
Okay. Thank you for that, Bruno. As I mentioned earlier on at the start, I see that there's quite a few questions that have been asked, but Bruno will be able to take some time out afterwards and he'll get back to you with the answer to your questions. The questions are all saved on the server, so we will get a lot of them after the event. So, ladies and gentlemen, that concludes our event today. As I mentioned earlier on, we will be sending you a copy of the presentation and the recording, and we hope to get that to you by the end of this week. So, on behalf of your presenter, Bruno, I would like to thank you for your time and for joining in today's event. Thanks again. You may now disconnect, and thank you and enjoy the rest of your day. Thank you.